we will connect secant and tangent lines and also calculate the slope of a tangent line. This is the 2.7 pre-class video. Alright, let's start by drawing a coordinate system and drawing a curve. Let's place a point and call it P. We're going to ask the question, if we put a tangent line at this point P, what is its slope? So what is the slope of the tangent line at point P? I can draw a line over point P and kind of try to guess what the slope is that would give a tangent line, but I'm not really sure. And the way we'll tackle this problem is by placing another point on the curve, and we'll name it Q. And at this point, it would be good to clarify what our points P and Q are. So let's let P have the coordinates a, comma, f of a, and let Q have the coordinates x, comma, f of x, and we'll see why in a moment why the point Q has x involved in its coordinates. But now we'll connect the points P and Q with the secant line, and we can write down what the slope of the secant line is, right? Because we've clarified what the points P and Q are in terms of their coordinates. So rise over run would give the slope of the secant line to be this. F of x minus f of a, all of that divided by x minus a, right? It's the rise over the run of the secant line. And the method to finding the slope of the tangent line is to let Q approach P. Let Q get closer and closer to P, and this should make you think of a limit. And here we are with the slope of the tangent line. We take the limit of the slope of the secant line as x approaches a, right? Because as Q approaches P, that means x is approaching a. The secant lines are getting closer and closer to the tangent line. What we can say is the tangent line is a limiting position of the secant lines, and the slope of the tangent line is a limiting value of the slopes of the secant lines. All right, let's apply this to a particular function, the function x squared, and let's find the slope of the tangent line at the point 2, 4. So when x equals 2, we have a function value of 4. And now that we have our equation for the slope of the tangent line at a particular point A, and all we have to do is plug in a, f of a, and f of x. A is equal to 2, f of a is equal to 4, and f of x is our function, x squared. And so this limit ends up turning out to be like this. And this is a limit that we've looked at before, that we've solved before. So I'll let you solve that on your own. And whatever the limit ends up being, that is the slope of the tangent line at the point 2, 4. All right, that's it for this 2.7 video. Hopefully you're ready for class.